Alright, we should be live in just a little bit. Hello everyone, and welcome to today's Blender livestream, where I am in the latest version, or maybe a few days old version, of Blender 4.0 Alpha, which we have some cool stuff to go over, with the main one being panels. So let me just show you one of the big changes. From there, let's just wait a quick second until more people come into the stream. The first thing is that the Add Modifier tab has changed, which I'm a little bit mixed on. I'm a little unsure about this one. You go, like, with the constraints, if we go and add a constraint, we have this menu where you can see everything at a glance, which I do like. It's meant to be quick. You just go there, and then you click on something. But with the modifiers, it's being changed so that it's one of these panels. I'm not sure if I like it. It feels like another step when this is supposed to be the fast way of adding modifiers. So, I think I prefer the older version for this, just because this part of the modifier tab is meant to add modifiers quickly, while geometry nodes is the more thought out process. Well, this just adds another layer of complexity. I get what they're going for, but I think for convenience for the average user, and not breaking every tutorial that came out within the past 10 years, I think the older version would be better. And then maybe, you know, the empty modifier thing is added on to it. You get what I mean? Just a little bit of feedback on that. But we could add in an empty modifier, and now we can go and check out what's new in there. So in geometry nodes, let me just add in something like the extrude mesh node, for example. Now let's go and make this into a group. So here, into a node group. Wait, how do we make something into a group? Let's see, make group. Where did that go? Group input, group output. I am confused. Wait, do I need to add in another geometry node in order to reference the other one? Maybe the make group functionality got changed when the new stuff was added? Not too sure about that. But let's go and add in all of these so we can see this is just a regular old modifier. Nothing too special here. It's doing its thing all nicely. Let's see, individual, and all of that. I can go and take that out. But the cool part is, let's go and add in a panel. Now let's go and drag this up here. Another thing is they got rid of the, I don't know if this is temporary or permanent. They got rid of the up and down arrows here, so you have to drag these into place. I would like to have the up and down arrows again, just because usability. But with this, with the drag and drop, we can drag the offsets into the panels. So as we can see here, we now have a panel. This does not show up in the modifier tab at the moment if we were to look at the end result, but they'll be adding that soon. So now we can collapse all of these settings into a nice, convenient panel. Now I can add in more panels and all of that. So let's go and add in another panel. And let's just drag, let's say, top 2 into here. There we go. So now, if we go and look at the output, we now have 2 panels, and we can label these. I'm not sure if I mentioned that. I keep hitting the wrong keys. So this will be 1, and this will be 2. Reverse order, but you get what I mean. So here we have both of these. So now we have dividers that work pretty well. One thing that I noticed is if you want to add in just a plain old empty divider by just adding in a panel, you can't. So right here, if we do that, the panel just straight up does not get shown unless there's something inside of it. Which I kind of wish we can just see the panel, like we can have a blank spacer if the panel doesn't have anything in it. Because that could add in some organization without needing extra code, in a sense. Because for those of you who have been on my streams before, the way I would make a spacer before, and I think this has been changed a little bit, is that I would have a string input with 0 name, and that would add in a little spacer. So here, it would be like, oh, what does this do? In the modifier tab, actually I can showcase this as well. In the modifier tab, if I go and put in a string input with no name whatsoever, we can see right here that we get just that, just a spacer, which is very useful for keeping things nice and organized. If I go and put in a few more inputs, so that it's not just a wall of text. It's nice just having that as an option. Now, that's good for the modifier, but in here, it will work as a spacer, but not as seamlessly as this one. So it would be nice if we had an official version instead of a workaround, but the panels are a good way of doing that, even if it is a little more cluttered than the very defined, here's a spacer. I'm just putting out my thoughts on the new systems and saying what the possible fleshing out aspects of it can be. But yes, many cool things will be possible soon. So now I'm going to open up, let's see, particle impact smoke to show you how this can be applied to an actual asset. So let me go into the geometry node editor while I go and load up everything here. Let's let this cook for the time being. There we go. So I'm going to add in a new geometry node in here. Let's see, empty modifier new. And then I'm going to add in the other geometry node, the actual bullet one. And those of you who have been looking at my Twitter or Instagram would have seen this setup, but I just want to make it a bit more clear. So here, actually, this will showcase the spacers better. So in the modifiers, let's see where geometry nodes, there we go. So over here, we can see that the spacers are very well defined, very contrasty, showing, okay, here's this section and here's the next one. So now let's convert it into the new layered system. And as we can see here in the modifier, the spacers still work, but they show up a bit differently than in the modifier. Not quite, they don't take up the full space. So now in here, I'm going to add in the panels to replace the strings. There we go. So let's just go and drag and drop them into here, which is actually fairly convenient for just moving them into there. It's not that bad. So I'm going to move those into there as well. So now, if I can exit the huge node tree, we have this, which is very nice. I should probably get rid of the string so that we can see what it looks like as in the end result. So let's go and remove that. Now let's go and add in another panel, and then I'll just replace all of those. There we go. So let's just go and keep putting these into here, which, as we can see, the conversion process is not bad. I'm very happy about that. I thought it would have been a bit more of a pain to do that. So let's just go and input more. Whoops. You have to be a little accurate with your placement of these so it actually goes like in the middle, because if you go in the actual middle, it says no. You have to be not straight in the middle, but on one of the sides there, if that makes sense. So here we have some very nice panels here. But as we can see, the spacers are not quite as contrasty. I think that's because of the name. I'll need to think about this a bit more. But yeah, now we can collapse these, which is very nice. The subpanels are one of the, I would say, one of the best changes to geometry nodes that we've had yet. Just because it will make everything so much more organized. It's so much less of a pain to keep track of. And it also legitimizes geometry node trees, essentially, compared to modifiers. Because modifiers, if I go in and add, say, an array modifier, they have subpanels galore, which is great. They also have checkboxes occasionally. I wonder, I kind of doubt that those will be a thing, because that's kind of unnecessary when you could just put that, like, in the actual panel. That's interesting. But as the subpanels are in the modifiers, we now have them in the geometry node modifiers. Now, once again, with the actual modifier right here, the panels are not rendered yet. That is coming later. But when they do come around, it will be so nice and so clean. So this will be, laser. I'll just type that in right now. Let's put in the collision into here so that we can see it working very, very well. Let's turn up the inaccuracy so that we can see that. I'm also going to turn up the speed. So this is a future product that I'm still working on because geometry nodes is still a little bit finicky with this kind of stuff. And I'm not sure if the particle impacts here will be a part of it, because it's a very advanced thing to do, because you need particle collisions and then essentially decals, which we can't do in Blender like they are in game engines, essentially. So it's all interesting. Let me check the chat for a quick second. Modifier tab changes. There's two things you can do about that. The first you can do is start searching just by typing now. In here, yes, so you can do like math. Oops. Shift A, math. Or is it, let's see. Oh, just in this modifier tab. So, armature, nope. I may be a little, I think I'm like 3 days out of date with the 4.0 version, so that may not have been merged yet in the version that I have. Second is that if your mouse is over an area, you can hit Shift A to add a modifier now too. If you are over an area, so Shift A. Ah, interesting. Okay. Yeah. I see how that would be useful, but I think people will be missing the old, just have one easy to use menu where you don't have to go into a sub menu to get the modifiers, to get the basic modifiers. I know that they're trying to eventually put everything in the geometry node system, but, you know, it just feels like another layer, and also the arrows will be forever pointing the wrong way, which is kind of funny. But yeah, just little opinions here and there, but it is very, very good that we finally have subpanels in geometry nodes. That's gonna throw me off? Yes, because every single tutorial that uses modifiers in the past 10 years will be invalidated by that change, which I'm not sure, like that change I'm not all for. That'll be very controversial. I think in here, having the old menu would be best, and then having the Shift A add menu here would be a good compromise. This part with the old panel system for the beginners, for the people who are just like, I'm not a geometry nodes expert, I just want to go and get the modifier. And then this one for, you know, just the, okay, let's not hit that easily accessible button, but press Shift A. This is for the people who know the shortcuts, know the hotkeys, know exactly what kind of data they're going after. Edit, generate, deform, and all that. But we'll see. 2,200 left. Just checked, you're getting average 50 plus subscribers daily. Interesting, Luz. Yeah, I'll need to keep an eye on that. I know the analytics. At least I can see the analytics. But yeah, I think it will be like 3 months before I hit 50k. 2 or 3 months. Let me check my analytics really quickly about that. Subscribers. Yeah, on average, it's about 50 a day, which I am amazed by. Because, well, 50 individual people clicking on my content, which is very, very niche, and saying, you know what, I'm going to subscribe to that guy. Have you tried making an words, sorry, it's a bit late here. Have you tried making an interstellar class vessel in Blender? I have not, and I don't know what that is. Are you referring to Interstellar, the movie, or like something from, I don't know, Starfield, Elite Dangerous, one of those? Because you're brilliant. Oh, why thank you. Right now, since I am rather tired, my brain is running at 50% at the moment. So, that brilliance is knocked down by a couple pegs. look it up. It's a cool ship design. I might. Yep. But yes, back to the panels. Very good addition. The one thing I did find very funny is that when you collapse nodes like this, they turn into these capsules, or orbs, as I say, where, as I said, sorry, as you can tell, maybe the music is a bit too loud in my headphones and that's what's tripping me up. Let's lower that by a little bit. You can see all of the sockets right here, but when you collapse these panels, they become invisible, and they don't get rendered when this happens. So you just have a giant orb with only 2 inputs, and I can get, actually, yeah, I can get rid of all those inputs. Let me try that. Is that possible, where I can? Let's just go and do that. There we go. An orb with absolutely no inputs and no outputs. That is hilarious. This will most likely be fixed soon. I think they may be thinking about new ways of making, you know, the collapsed panels show up. But yes, if you want an orb or a pill design without any inputs whatsoever, you can. It's hilarious. But also, isn't it incredible that a node that's that big can easily just be compressed entirely? And here's a good opportunity to showcase what happens if you have inputs and outputs. That just happens. So let me go and just add in a few more inputs. Integer, and this will be Boolean. There we go. I'm just going to add in quite a few inputs. This will be object, another float, or constant. No, it's a value. I'm getting my Unreal Engine terminology mixed up. Okay, and then one more integer. So what happens if you have a ton of inputs like this? They're all hooked up in this way. Well, they just get compressed. Just like that, which you may think, oh, that's a bad design, but I'm like, no, I think that's the best that you can do with those inputs. Just have them collapse, where you can see, oh, they're going into that part of the panel, but you cannot, like, directly interact with them. You can cut them off, which I'm actually surprised that does that. But I think that's the best way of doing it. When they're collapsed, you see the inputs, but they're still collapsed. And you can't edit them, which is good because, you know, what if you could attach something into there? You can attach... Okay, so that's a little bit of an error. You can still attach things into there. So that should not be doable. But it'll only attach to the first one. Interesting. Huh. Interesting. Can I go and... Oh, I can take out these as well. You just have to be a little careful. And you can extract from there as well. Okay, so that probably shouldn't be able to be done. Again, this is the first iteration of the panels. They're gonna be buggy, they're gonna be iffy. I'm just going over what is happening and my little impulses on what design changes could be made. Anything else? Oh, another change that I want to point out is that before, you would always need to have the geometry output, or any outputs, up at the top here. We can see this kind of with any of the other nodes. Say the extrude, the outputs are always on top, the inputs are always on the bottom. This is changing with the new one. We can add in a new output socket right here, and we can place it anywhere we want. So as we can see right here, there's now an output just in that panel, which I think is a very good change. Because, you know, you don't have 15 inputs all lined up here, and then with the panels, it seems to be absolutely necessary. Great, you found a glitch and it's documented. Well, that's part of the goal of these live streams, so that everything I do is documented, so that other people can take a look at it. This stream will probably only be up for like a few days, because I imagine that they already know about this, a majority of these things. but this is more just for information and updates. In other news with geometry nodes, I'm not sure if there is any immediate other news. The repeat zone, anything new here? Nope, and we still don't have the loop input thing into here. I'm very saddened by that. Wait, 4.0 is already out. No, it is not. 4.0 is coming out in like October or November of this year. I am using the alpha, which is basically the version that the devs are currently developing, so that the users can try it out and find bugs and suggest different design choices. Which, I should mention, if you're going to pitch a design choice, do it through the proper channels. Do not go into the Blender developer chat and then say, hey, you should try this. The Blender devs do not appreciate it. There have been quite a few people who have done that, and they always say, hey, go to right-click select or the other ones to suggest your pitches for features and such. It might take a while for it to be implemented just because the devs already have a plan for the next like 2 years, but do it through the proper channels if you have a suggestion. If you have a bug that you think needs to be fixed, make a bug report. Blender has a button for that with help, which is report a bug, and then it will autofill like your system's information. But with that, you need to reduce the bug to just the broken component and all of that. There's a process behind it. But if you click help and report a bug, it'll tell you what to do. But again, make sure it's a bug before you send it, and make sure it's fixed. Make sure it's not fixed before you send it. There was one time where I reported a bug, but my build was like 3 days old, and they fixed it by the time that I uploaded my bug report, which was very funny. But also I was like, oh no, I inconvenienced them by being like, hey, there's this bug. They were like, oh yeah, we already fixed that yesterday. But yeah, anything else? I'm kind of running out of content, if you can't tell. I do have one plan of something to do. I'm going to wait just a little bit to do that. Alright, anything else? Oh, the rotation nodes! Actually, wait a second. Rotation to Quaternion, yes! The Quaternion nodes have finally landed. I'm not sure if all of them are here, but Quaternions are a very, very interesting thing, which I will have to think about. But this will lead to a lot better physics implementations eventually. Let's see, let's go axis angle to rotation. So this, rotation, there we go. So Quaternions, we can mix between, we can mix between 2 rotations now. Oh, this is going to be good. Hopefully, we also get, I know that the Blender devs are talking about matrix transforms as well, which will be amazing once that happens in the future. I don't think it will be 4.0 though, but keep an eye out for that. So, let's see, instance on points. Oh, so how does this get converted? So that's incompatible. I think I need to use a Quaternion to rotation. No. Wait, how do I convert a rotation to an Euler? Ah, okay. So we have to do that into there. That will be confusing. That's going to be confusing. So there's going to have to be some renaming later. But at the very least, the colors will tell you what's incorrect, shall we say. So, Quaternion math, those of you who have done rigging or anything like rigging in the past will know that Quaternions are essential for making animations with rotations that make sense and that don't have gimbal lock. So gimbal lock is a mathematical thing and all that. But basically, Quaternions in a nutshell are, we have one rotation, objects rotated in one way. Actually, I can visualize this. I have a 3D program at my disposal currently. So I have an object in one rotation, Let's go and keyframe this here. And oh wait, let me make sure that this is a quaternion. And then we have an object in another rotation. But we want this to rotate in a kind of linear path. Well, that's where quaternions come into play. It'll just draw basically a line from one rotation to another using fancy math, and then make an accurate, smooth transition from there to there. While Eulers are good for robotic joints, gimbal lock can become a thing. So let's say I rotate this around quite a bit. We can see that it does not... Wait a second. Is this still rotating with the quaternions? Here, let me rotate this a bit around. There we go. We can see that it doesn't just do a standard transition. It does a lot of different things. So Eulers are good if you need one thing spinning indefinitely in one direction. Quaternions are good if you want it to go from rotation A to rotation B without any mix-ups whatsoever. Just straight line. Just interpolate regularly. So you may be wondering, well, what's the use of that? Well, that's basically what powers a lot of games and all that, all animations, all games. And I think this might allow for angular velocity, but I need to check up on the math on that, which means I may be able to make my own rigid body physics if I am careful enough. But we'll see. We will see. Anything else? Let's try using this with a cube. Let's try this out. So here... Oh, right, I need to go and create another rotation. So if we mix between these two... that seems like a linear rotation. Actually, let's use an Euler to rotation. Which, this is going to be extremely confusing for people. Rotation, but that's a rotation there. Aren't these supposed to connect? The colors do help with telling the difference, but they will need to rename every rotation into an Euler for the data input to make sense. So here I'm going to put this in a random rotation. And this should mean... Yep. It mixes so nicely. And you may wonder, well, wait a second, that is like 600 degrees. Shouldn't it be spinning a ton, like around and around and around and around? You may think so, but no. That's what quaternions do. They just take, hey, where's the end rotation? Okay, it looks like it's in that direction. So let's just rotate it regularly. So this, like if you were to track one of the corners, it would go through just a regular, completely straight arc from one point to another. No wibbly wobbly that like you get with Eulers. This is a terrible demonstration, so I apologize for that, but I just wanted to showcase only that. Speaking of which, I'm going to go and create a new scene because I want to try one thing before I go to bed tonight. Because it's late. It's late for me. I was out and about today, going to fairs and such, so I am tired. Like a normalizer? Kind of. A little bit. It's a lot of very complex math that uses imaginary numbers. I do not know how to make it in Blender. Other people have, but it's complicated. It is extremely complicated. So, let's just say I'm glad that people much smarter than me decided to implement it by default. Let's see. This acts as an angle node. I needed for, I forgot what. I think it was trying to figure out a local offset method using the UV tangent and normal. I needed this to basically undo the rotations. I'm not sure. But this will be really good. Oh, rotate vector and then using... Oh, this will be interesting. So let's use a transform node because I want to see how that works. I need to discover how all of this affects stuff. Oh, that is interesting. So this will rotate a vector to a quaternion rotation. That will be interesting. So vector input. So that'll be like 1. Actually, wait. Let me test this. So, yeah, how do I showcase this in a good way? Let's use a point, and the position will be the vector that we rotate. So the centerpiece, the center here is 0, 0, and that is currently at 1. But if I use a Quaternion rotation, but that's using Eulers. Oh, that is weird. Okay, yeah, okay. So it has a Quaternion input, but it's using Eulers right here. Let's just say that it's a little messed up. So rotate vector. So here's the old one, which can use the axis and the angle, which this was kind of their placeholder for Quaternions, if I am correct. Let's see. Utilities, rotation. This is very, very advanced math, so if you don't get it, don't worry whatsoever. It is complicated. So axis and angle. But yes. Oh wait, I know how to showcase this. Or do I? Let's see. I have one rotation and I mix between that and another. Imaginary numbers are 4-dimensional. I think with Quaternions they are. Which you're like, wait, how does that work? It's complicated. It is very, very, very complicated. So say, what if I were to mix between that rotation and that part? Oh, that's for matrix math. That's mixing between one object's position, rotation, and scale and another one. That's where we would need matrix calculations to make it a lot easier. But for the moment, rotations make this a lot easier. Oh god. So let me just rotate this in a very weird way, so that I can use a transform geometry node, so that I can mix between one rotation and another. Okay, this is complicated, but hopefully I can demonstrate this in a non-odd way, in a non-weird way. So let's use original, and I'm going to mix between rotation 1 and 2. Let's go and take a look at this. So here we can see, when we mix between this, it's not going through a simple arc. Here, let me just get rid of the position weirdness with this. Actually, I'm going to link object data so that we can clearly see which sides are which. So let me assign another material here. Let's make this one red. And this one to be blue. Oh, not that one. Whoopsie daisy. This one to be blue. Blue and blue. Okay, now we can see the differences in rotations between these two. So if we just rotate these vectors, we can see that it doesn't rotate in a smooth arc. It does this weird curve thing. It doesn't just rotate along a single axis. If you look at this point, it doesn't travel in a straight line relative to rotation origin. It just goes around. That's not what we want. So the new Quaternion rotation, this is for, again, the math nerds, myself included. Quaternion. Euler to rotation. I think that should be labeled Quaternion, because that will mess people up. Because currently, this is a rotation, and then it says Euler, and then to a rotation. Weird naming scheme, that I think this should be rotation, and then Quaternion, because that's Blender's native scheme at the moment. Because here, it's rotation, Euler input, rotation, then rotation. And then I'll have to convert it back into an Euler to go into the rotation input. To Euler. So as we can see, that's not good. That's not good in the naming convention. I think they'll probably change that once people complain about it. But again, a little weird. So here we can see the difference in the mixing of those two quaternions. Here, it just goes in a very linear fashion. No weird wibbly-wobbly gimbal stuff. So here, it'll just go from there to there, no worries whatsoever. So if I were to have the midpoint here, it is the actual midpoint between those two rotations. And that snapping, is that supposed to be happening? I think that is, because it's literally trying to find the midpoint. I'll have to double check. So let's showcase just the vector, or in this case the Euler version. So here we can see it rotates there and it rotates there. So if we have this one at 50%, it's just like, oh, actually, is that even working? My gut is saying that I think it is working. Just mixing halfway between two rotations when this one is going all berserk may be weird. But here we can see linear rotation and then weird rotation. I'll kind of just... These aren't the same, right? I'm having to double check. Having to double check. So here... I think it's different. Wait a minute. Wait a second. No, yeah, this isn't mixing the way it should. Oh, the rotation input is not the Euler. Wait a second. It's not the Euler input. Oh god. So this is a huge level of weirdness going on with the rotations. Is it confirmed that the Quaternion math will be in 4.0? Most well, Quaternion math. The Quaternion nodes, yes, but do we have Quaternion math? Actually, oh, we're getting some new math, truncated modulo and florid modulo. Interesting, those are new, I think. But the rotation nodes, all of these new ones, I think, will be good. Interesting. So there isn't a way to extract the actual Euler data from objects. That's weird. Because here we have like 1000 degrees. Oh no, wait, over there it seems to be mixing perfectly. But we can't get this data into geometry nodes. That's weird. Oh, and here we can see that, well, actually, rotation math is weird, and it's so weird that even the Blender developers are, they have inconsistent naming. And yeah, the convention is weird. Because currently the rotation inputs, that's in radians. But when I convert the rotation Euler into an actual rotation, this is weird. Okay. This is starting to melt my brain a little bit. So, yeah, I think it's time that we pivot to just what I was planning to do for this one, for this live stream, because I wanted to get just a little bit of productivity done. I have a little idea in my head, and I'm going to just make it really quick because we have 20 minutes. Let's see if I can make this in 20 minutes. So what am I going to make, you ask? I'm going to make a piano key, well, piano keys, that do a little bit of wave when they get tapped on. So let me just model the most basic piano key you have ever seen in your life. There we go, piano key, wonderful. And then the black bars, I'll try doing that next time. Or maybe I'll just add that in post. Actually, you know what, I'm just gonna try it here. So the black bars are if I remember correctly, they're about yee big and kind of like that. But again, they're not right there. They are right in the middle here. So, wonderful. As you can tell, I played piano 10 to 15 years ago. I forget. Let's just scale that up. I'll need to look at an actual picture of a piano, but the actual part that I want to focus on is the geometry node section. So I'm going to use a curve line for this. I'll read the chat in a second. I can see that there are some questions there. But here I want a horizontal line. Yeah, that'll be good. Let me just rotate these so that I can instance them well. Control A, rotation. I'm going to resample the curve based on the length so that if I want to extend the piano to a ludicrous amount, I will be able to. Then I'm going to instance on points, and that will be our piano key right here. They're too big. So let me just scale it down by like 0.5 scale. It seems to be good. The piano keys are still too big for a regular piano, but I am not going to worry about this. Oh, funny thing, with the resample curve node, I put in a bug fix for that a long time ago, because I noticed through my testing that this node had one less point than it should have. So the Blender devs literally had to put in the code value +1 in order to make it accurate. This was before, I think this might have been before they transitioned to the Fields version. So this was like, I want to say like 2.9? 2.9 something? But yeah, I contributed to the resample curve node through bug fixes. Which, hey, if you want to contribute to Blender, if you notice a bug, make a bug fix for it. It will help us all out. Okay. Do you know it's possible to derive or partially derive a function in geometry nodes? I'm not sure what you mean by that, but probably, yeah. Quaternions are alien math, some say. I agree with that sentiment. I wholeheartedly agree with that. Okay, now for this, I want to add in the piano hit and the piano wave. So for this, I am going to put in a simulation zone, because I'm going to store basically a grayscale value that will affect the X rotation of the piano keys. I'll be going at speed because we have 18 or more like 17 minutes left of the stream officially. So to do this, this will be complicated because I need to add in a velocity and a current rotation. So this will be, and this is only on one axis. Quaternion math will make this possible in other axes, but that's complicated. Very complicated. So if I ever want to add like rigid body physics into geometry nodes, it will be a monumental feat. Especially for ones that are at speed. And I will probably need the for each loop node, which doesn't exist yet. It may exist in 4.1 or 4.2. We don't know yet. But we will see. We will see. As you can tell, there's a lot of math on my plate. So, rotation, velocity, and then just the rotation, the current rotation value. So how do we do this? So I'll do this like I do the position, rotation, and velocity stuff. So for this, we add the rotational velocity to the rotation every single frame, and that will contribute to the new rotation value. There we go. So this will be update rotation. There we go. Oh, and also I need to input this into this right here so that we can visualize what is happening, so that we can actually see the result. Again, advanced math stuff. And now for the rotational velocity, if I do this, we can see, oh, it's actually rotating. This is incredible. Wow. But we need to make it so that this actually functions as you would expect. So we need to make it so that the rotational velocity gets kept every single frame. So right here, if I add 0.1 every single time, we can see that this starts to speed up. Okay, let me reset this by a bit. So this is the speed getting faster and faster every single frame, which is good. We just need to make it so that it's accurate to what we want. So what do we want? Well, first of all, I'm going to make it so that the velocity will fade over time. There will be some drag to it. So right here, if I do this at 0.95, this will basically make it so that it can't go over a certain amount of speed, simulating drag, which is what real life has. But then I need to make it so that an effector and the proximity to an empty will add some velocity. So let me just drag an empty into here. And I will say, well, according to the distance to the vertice's position, so the distance between the vertice's position and the empty's location right here, we can get the distance to there. And if I use a map range, let's make this go in between 0.5 meters. It will add 1 to the velocity. This will be way too fast, so I will lessen this to 0.001. There we go. So here we can see that wherever I move this empty, it will add to the velocity, which is nice. Let me move this up by a bit. There we go. I will make it so that this will be better, so that we can see it starts to speed up, but then they also start to slow down. So we have parts of this working. I think this may need to be like 0.9, so that they will, okay, they speed up, then they slow down, and so on. So the last part that we actually need is, well, how do we make it so that, actually, I also need to disable the cache, that this will keep updating properly every single time. And they fixed the cache in 4.0. I am incredibly happy about this. It's so incredibly nice. The cache just works as it should have when it first launched in 3.6. But better late than never, as I always say. Now, to rain on my parade, I'm just going to do a little check to see if materials are still broken. Another thing that simulations shouldn't really have shipped without. Materials are still broken. That is very unfortunate. So currently, a lot of effects that I made in the 3.6 alpha and beta are still broken. So I'll need to wait until possibly 4.1 or 4.2 until materials are fixed. It's unfortunate, but simulation nodes are still broken in that regard. And that was changed 2 weeks before 3.6 officially shipped, during the beta, which should not have occurred. The beta is supposed to be where things are finalized and bugs are fixed, not when new material changes are introduced causing new bugs. It's unfortunate. But the cache is fixed, so that's a step in the right direction. I'm very happy about that. So now to make it so that the keys reset to the original position, as they should. Again, when you press a piano key down, they should wobble back into place. So to do that, we need to compare the current rotation to the target rotation, and the target rotation is 0. So to do this, our base value will be 0, and we'll compare that to there. So we will, after that add, we will put this into here, which this will be slightly inaccurate due to the velocity being accounted for before then. But here we can see that it is functioning. I just need to limit it. So let me I should be labeling all this, but again, I am working at speed and am lazy. So here, this will try to move the current rotation. This will be target rotation. So this will try to make it go back to its original spot. So here we can see, let me turn off viewport denoising as well. Here we can see that the wave is happening. It's wobbling back into place as it should. Let me go and bump up the amount of rotational velocity that gets added. So here we should be able to see, and they wobble back into place. So here it's just I probably should have these going the exact opposite direction because it'll be pressing the piano keys down. But yes, that's why I wanted. Physics keys, essentially. Let me go bump this down by a bit more. Now, you may be noticing that I'm moving the empty where the particle origin is. That's because that's where the proximity is taken from. It's a little unfortunate that that has to be done, and I can make workarounds to make that work. But for now, it's fine. Like here, we just have do-do-do-do-do, 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 do-do-do-do-do. Now, one thing that I do want to do is make it so that this will only hit like one key at a time. So it'll be do-do-do, do-do-do, it'll just pop in, hit one, pop in, hit one. But I want it so that the velocity transfers to the other ones. So I'll use a blur attribute. This will make it so that the velocity will be shared with its neighbors. As we can see, it is, but it looks like I need to blur it after the new changes are made. Let's do that and see how it works. So here we can see that that does happen. It's not making quite the wave that I was hoping for, because, again, rotations and all that. But this is making it so that it is being shared. What happens if I were to multiply this? I'm in the experimental stage. Dang. To know it would react so heavily to that. Oh, yep, okay, yep. Will you settle? You will not. Let's try to find the perfect point where it will settle. Oh. Yes, it will not settle. Okay, so if we do that, it'll keep... Yeah, that's why we don't multiply above what it should be. It is funny, though. Like, just by that, it'll keep wobbling, and it'll keep doing its thing. Let's see. So with that, it keeps getting shared. But again, it keeps multiplying and multiplying until it freaks out entirely. Wonderful. Oh, but with this one... Oh, that explains it. Yeah. Okay. Since this is 1.1 and that's 0.9, they will be at equilibrium. In theory. So here... So this just means... Okay. So one thing I was kind of hoping for was to make the actual wave math. Here, let me just go and label all of these for... Because we have 27 people here. Rotational... Velocity... Target rotation... Effector... And that's caps lock. Effector... There we go. And this will be... Old velocity. Whoop. Old velocity, there we go. So to make the actual wave math, I need to think about this. How do we make actual wave math occur? So if one, say, right here, if one key gets pressed, how do we make it so that it actually waves across the stuff? How do we make it so that it actually waves across everything else? I have an idea, but this may end up just being my reaction diffusion algorithm. So what if we take the blurred amount, multiply it, but then subtract it by the original amount? If I do this perfectly, it may result in a wave effect. But this may also be it's not quite the recipe for reaction diffusion. So let's go and try this out. So here we have that. As we can see, 2. Oh, we can see it's kind of working. So here it's like, it's kind of working. Almost. It's almost working. Let's see, let me increase the effector so that we can actually, there we go, so we have that. So it's not causing the, the ripple effect that I want. So how whoop, that's a bit too much. 2.5. Okay, so 2 is the equilibrium point for there. I forget how the math is done. Here that looks like a wave, but that's just because I'm moving that around. Well, it's not actually spreading. If I had that 1. Oof, that is, not the best. Or what if I made it? Let's see, wait. I'm thinking, currently. Dangerous territory. Wait a minute, I think I know how to do this. I'm doing it wrong. I need to make the target rotation the blurred rotation. So here, let me set this to 0.99. It's... that is intriguing. Oh, no, it is causing a wave. The wave is occurring, it's just not, settling. So here we can see wave go up, and wave keep going. So the wave effect is there. It's just forgetting that it's still, you know, wants to go back to its original spot. So maybe I need to divide this value. Let's see. So what happens there? Divide by 2, sorry. Oh, it's working! Okay, I just need to turn that up by a bit more. Let's see. So the blur amounts. Wait, why was it picking up? So here we can see that the wave... It's trying to do the wave, but it keeps dissipating. I wonder if that's because of the blur aspect of it? Is that how... Is that how waves work? Or am I doing this completely wrong? So that is very interesting to see. Wait a second. We're observing a physics effect. Wait a second. So the rotation goes around, but then when it flips around to the endpoint, it flips around even more, and then it causes that to happen. I've seen that happen in real life. Obviously not in the simulation, because the simulation is zero gravity and all of that. But this is... physics. Physics is happening here. And it makes sense, because the laws of physics, like... If we look at this, that's the physics for, you know, applying speed to an object, and then this little bit of math, sans that. That's part of how the universe works. Like that could be eliminated, but drag, that's drag. You take the velocity and then multiply it by a little bit less. That's drag. That's a drag force. And then, you know, you apply all that, and then we have the target force and all that, but physics. Simulating physics in a very simple way. I didn't know that was possible. And just to show you how weird this is, the keys don't even exist to the simulation. The simulation is just a gray value. Just, to our eyes, the value is just gray. It's only one number per point. But the data is being shared. This is interesting. Adding gravity, that's a little difficult for me to do because the rotations are in radians, and I would have to say, okay, once you get to this level of radian, like, I think it's like pi divided by 2, that's down, and when you get to an interval that is like positive pi, that equals you're up. So the I could do it, but the translation will be a little bit weird. But again, these are supposed to be piano keys. But yeah, we have that. Like, that's so cool. I love how it just whips around, and then it causes the chain reaction to occur. As far as I know, no data is being added into the system. Okay. Let's up that by even more, so that's 1. So here it's like... That's an... Whoa, that is interesting. So still, no data is actually being... Or, no, some energy is still being lost. So we have that, and then... That's so weird. That is a physics phenomena. Actually, just to make this look a little bit more pretty, which I should have done before, let's add in a... I do miss the main panel. This new thing, I'm still... I can get used to it, but I feel like the modifier tab is supposed to be the easy access part, while the geometry nodes is supposed to be the advanced section of it. So there we go. We add in the bevel, make it look fancier. It's almost like a slinky in an odd way. Actually, yeah, it is kind of slinky math to a degree. So here, no, if I set this to 1, no energy is being lost, it's just being transferred. So this will keep going into the end of time. No data is being lost, it's only being transferred. No velocity in this case, it's just being transferred to the next one in the chain, causing the wave effect. Brilliant, and if I change that, I think this will just mean... Here, let's go and reset this. So let's go and add in some more. That just means that the wave is a lot. Yeah, okay. So interesting. Actually, wait, is this even mathematically accurate? Because this... It is kind of. The thing that's happening here is that the target rotation is moving from one to the next. So this one gets a new target rotation based on the kind of velocity output. So this one is saying, oh, my target velocity is the average of these ones. While this one is saying, oh, my target rotation, sorry, is the average rotations of these ones. So I'll lean more that way. It's so interesting. But it is kind of slinky math, in a way. Looks like a virus. It looks kind of like DNA, so yeah, I can see that. I still need to make it so that it will decide to try to default to, you know, the average thingy. So here, if I do, that's supposed to be divided by 2, not by 0.5. G, okay. So that's causing a wave to occur, and since no data is being lost, that will keep going. Let me average... Okay, so that makes the wave different. This is interesting. So I did get the wave math working. Now we added in another part of the wave. This is intriguing. So if I multiply that by, whoops, 0.99, that'll be like the drag to the new rotation to the default, which is 0. So incredibly interesting. I just realized that this is going at 24 frames per second, which it should have been 30 because the stream is at 30. So that should give a much smoother result for all of you. This is the weirdest. Oh wait, I know what I need to do. That's at 0.3, I need to make that 0.1 again. So here we go. There we go. We are seeing the wave math occur. This is very, very amazing. I like it. So how do we make it? So it is relying on the target rotation method. Actually, wait a minute. Yeah, it's taking in the target rotation amount. But it's taking the rotation and the rotation. The differences of those two. That does make sense. Here, let me go and move this part up here, move this part down there. Okay, so we have this. Let's put that into a frame as well. So that's the target rotation. Target. Yeah, and then that does that, and all that. Let me just move that, so, yep. This is, again, very interesting. I haven't, I need to make that so that it shows up only on the first one. And then I need to blur that by... I don't want it to freak out in that way. This is interesting. Okay. Let me have it so that the empty starts out there. And then just zoops out of there. Zoops? Is that a word? Zoop? Just like that, so we get a little bit of wave current. Just a little bit. Oh wait, I think that may be getting stronger. Is it getting stronger? Okay, let's check that out. No, I think the wavelengths just converge. Which, just to showcase this part again, I can use an extrude mesh node, set this to vertices. Then I can use the rotation to offset where that's going, and let's make the vector just up. So here's another way to visualize the data, and I need to set the curve to a mesh. Here we go. Okay, so here we go. Sound waves, kind of. Just waves. They could be sound, they could be whatever. But just multiple ways of visualizing the same data. My goal was to visualize it with piano keys, but we can see how that's going. It's interesting, but, you know. So here we should be able to see both. We can see the rotation values in a linear axis and in a rotational axis. Both are quite cool. This is extremely, extremely interesting. Now, I should also probably transform this upwards so that we can actually see this. Oops, 0.5. There we go. So we can see both the piano keys and just the raw data coming from a kind of graphed medium, if that makes any sense. Again, I'm tired. We are past 1 hour, so I will have to call it here, probably. Let me check up on the chat real quick. I did what I wanted to do, which is good. For the black keys, let me just see if that will look all right. Join that into the fray. Now, I know pianos are more complicated than this. I know that they have keys missing every so often. I could implement that, but at this point, I'm kind of just tired. So, I probably won't even have those in the end result, because I know every person who's played a piano, which many people have, will be like, that's not right. And I'm like, I'm not going for realism. I'm going for style. It's just supposed to give the impression of piano keys. It's not actual piano keys. You can tell that my tired brain is starting up, because I get a lot more talkative and a lot more dramatic. I have two modes, either being dramatic in my speech or just getting plain old tired. It's very funny. The body reacts in very interesting ways to being tired. Sleep deprivation. Shouldn't the key movement be limited to only downward? Yes. Yes, it should. But, this is not accurate. So this is just going to be weirdness. It's just going to be weird. Actually, I'm going to not even include that top part. I'll just join that into here. And remember that I need to sign. There we go. It's a Tom and Jerry piano. That was an inspiration behind it. Bro, your stuff is always so impressive. Why, thank you. Please consider making a full course on geonodes. I am not professional for that. As you can tell by the stream, everything is very impromptu. I do not know where I am going with these projects, which means that I get very interesting results. But it also means they're not entirely predictable, which is why I don't make courses, or even plain old tutorials anymore. I don't know where these things are going to end up. Quite often. I have an idea, and sometimes they can be executed, like the Mimic, like the robot arm effects, like many others, even this one. It's executed, I was able to accomplish it, not entirely in the way that I planned, but in a way. In a way. Oh, that's interesting. So we can see that the math isn't perfect, because the target rotation gets divided. It gets transferred properly, but it should be... I find that so amusing. So incredibly amusing. It's just donk donk donk. And there still is that wave happening. We can see it's actually working perfectly if we look at the data. It's just vroom, 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 vroom. It's passing along perfectly. The problem is that it's not defaulting back to 0, which is why I had that divide. But the divide, as we can see here, it's not accurate. It should be just going back to 0 properly. Like here, yeah. Actually, even the, like, that's better. But this is making me realize that some of the math is still incorrect. Like, the wobble fade that we have, like, that's just getting accumulated. If I set this to 1, we can see that the wave is still being dissipated, which I don't know why. Is it just because it's being distributed? Is the value still there? Is all... no, all the energy should still be there. Even with the blur, all the energy is still there. It's just being spread out. Okay, so no energy is being lost. Just the issue is that it's not going towards the value it should be. Hmm. My math is still wrong. Wait a second. Wait a minute. Am I doing this all wrong? I have a theory, and this theory is probably correct. I need to get... Do I just compare a blurred version of the rotational velocity to its actual velocity? And does that fix all of it? One way to find out. So this, I will set to 0 for the base rotation. Let's set that to 0.1. I should have saved this file, but I am super smart in that regard. So here. Why not? Oh, wait. Interesting. I'm going to set that to 2 just so that we can see that. What? Excuse me? Something's telling me that it shouldn't look like that. And it's not even being transferred. Is it? No, it's not. No, this is not correct math. So the other version was... Oh, shoot. No, okay, that's fine. Now, what part of the math am I missing? We got the wave section, and it looks really amazing. I just need to figure out how to make it so that it actually, you know, goes back to the water level. Or I'm saying water because of waves and all that. So how do you do that? So there's the wave force. Let me think about this. So this is a wave if there was no gravity whatsoever. So if you just pushed a bit of water, or like a chain, think of a slinky, a chain, a slinky, or something like that. Those have wave physics applied to it. So if you were to move it through space, but one part at a time, it would do this exact method. It's still moving downwards. It's just doing the kind of slinky effect. How do I make it so that it goes back towards its level? Towards the level it should be. Oh wait, and that needs to be 1. Yeah, that's the accurate version. Wait, but wait a second, what happens if it is 0.1? Huh. It's not accurate because... No, it looks more faded in this way. Like here we can see that the wave is better. And that it's still doing the slinky thing. So that's what would happen if a slinky were in space and you only moved one thing. And rotational momentum does not factor in at all. Let me check the chat real quick. Can you make your machine learning race cards GeoNodes project downloadable on Gumroad? Maybe? Maybe. I think I was waiting until 3.6 was out to release it. But, yeah, 3.6 is out. I must have forgotten about it. With 3.6's release, since there was the material bug that was introduced, again, 2 weeks before the release, and then the cache bug being broken, a lot of the projects that I wanted to release either couldn't because of the material thing, or shouldn't because of the cache bug. Which currently, both of those bugs still exist in 3.6. So with quite a few of those, I'm still waiting until 4.0, like with my Rubik's Cube slice fracture. That one I cannot release because the materials just get wiped when I use it, which is so very annoying that the official release is broken and will be broken for potentially more than one update. So that one cannot be released for a few more months if that material bug does get fixed in 4.0. If it doesn't, we'll have to wait half a year, which is very annoying. But yeah, with the machine learning one, I usually disable the cache for that one. But I think I could enable it and it'll be okay. It's just if you change values, you'll need to reset the cache to see what happens. So I'll have to check in on that. What else? I've been going for an hour and 20 minutes. So I should wrap this up and figure out how to do the math. The accurate math some other time. Let's go and copy this. For the one other part of the accurate math, I would just want to see what happens if I do the old target math that I started with. So here, as we can see, I want that to be 0.1. So each one will try to go... Oh, there we go. It works. So there we go. We got the wave math working. That is funny. But it does make sense. Yeah, no, all this does, target rotation, and this will be wave, rotation, wave rotation value. Okay. It does make sense. So if you think about wave physics in its most literal fashion, water likes to be with its neighbors. So if, say here, water's down here, the water wants to go and be with its neighbor down there, but it also wants to be with its neighbor up there. So it tries to go towards the kind of average position of it, if that makes sense. So that will be its target point. That's where I'll try to go to because of surface tension and other things. No, not necessarily surface tension to a degree, but sound is a wave function, and everything is sound. Everything can transfer sound because it's just the wibbly-wobbly physics. Oh, dang, that's the thing. Oh, I'm a little... I just realized. I can do 3D sound visualizations now, because I now know... Dang it. Oh, this was so simple. Okay. So, I can just get rid of these two multiply nodes, because they're just not needed. It's more accurate if they're not... Well, they're probably more accurate if they're not there. So let me just go and delete that. So that's how you do a wave. Correct me if I'm wrong in the comments. But if that math is correct, that is absolutely incredible. Let's make this just a value so that I can see where the target is. The target is 0. But then the target rotation here is just saying, hey, you know, go towards the water level because, you know, water exists underneath and it can't compress. So it's like, oh, gravity tells you, you know, physics and all that. My tired brain is trying to, it's conflicting with my math brain, which leads to some discoveries, but also a lot of confusion. So I hope that is entertaining, at the very least. Wave physics. Dang. I wish I developed this on its own live stream, because this would be actually good information. You know, since this was the research and development live stream. When I go and maybe try to make it work in 3D space, that'll be another live stream. We'll see. Wait a second. You've seen when... Set that to 4. So there we can kind of see the wave. We loosen it up by a bit. Have you ever played with like a rope or something and then you snap the end of it? Again, pulling from the Tom and Jerry references. When you snap it, the wave rolls along, but it doesn't affect the original. But wait a second, that's because you lift it up and then you snap it back down. You force it to go back down. Well, this one, it would be like if you raised it up and then just left it. Again, with the Slinky in space analogy. So if I were to lift it up, then force it back down and keep it down, it would cause a wave to just send it. Actually, yeah, and we wouldn't even need the target value. So yeah, that's what could be done. If I just set the initial point, if I just set its rotation value, or, yeah, if I set its rotation value to go up and then snap back down, it will just do the thing perfectly, or semi-perfectly. Do I try? What the heck, I'll try it now. I'm going to disable this part as well, because it won't need target rotation, I don't think. So how did you learn geonodes? Through testing. I guess kind of trial and error. Let's use an add node here, but I only want this to be added to, yeah, the offset to there. I only want to be on the first one. So I'm going to use a switch node. Switch between that and this. But yes, I was there when geometry nodes was first created. I saw it being developed in real time ever since the first tweet with particle nodes, which never became a thing. They transitioned to geometry nodes from particle nodes, and then looped back around with the simulation nodes, even though it's not quite as fleshed out as the rest. Wait, I want this to overwrite that. So, yes, so this one, raise it up, so it goes back down. Okay, so here, I go, boom, boom. There we go. See? I just simulated what happens when you go and whip that. It works. I'm a genius. Part-time. Here we are. Lovely. Alright, I will have to get going because I am almost at 1 hour and 30 minutes. But there we go, see? I'm a genius! Part-time. Some of the times, I am a genius. But yeah, it works. And then it gets dampened because, again, that end key is being clamped. So, if anyone has snapped a rope that's taut, you'll see the wave go to and fro, but if you're still holding it, it will dampen it. Okay. I finally figured out wave physics. I've been wanting to do this for quite a while, but I thought it was just way too much for a little small Ben brain to figure this out. And come to think of it, this can work in 3D now. Allow me to demonstrate. So I'm just going to use this version. So let's use a grid. So here, this is going to work in 3D space. I'll have a 100 by 100 grid. So as we can see, let's set this to be 50 by 50 because I think that's a little Oh, not 500, but what the heck are you doing? There we go. There we go. So this is doing the snapped thing. I think is it getting taller? Yeah, it is getting taller. Oh, wait a second. Okay. So I think I may need to square this because square one aspect of it because this is a 2D grid. Let's try setting this to 0.1 again and seeing how this works. Yeah, but I suspect... Okay, so we have the wave physics working, but it's not accurate. We can see that we're getting... Here, let me go and... We're getting an interesting pattern, but it's not accurate. But here we have that. And it bounces off the walls, which is very interesting. I think one part that's adding to the inaccuracy is because all of these points are laid out in a square grid. The ones here do not get blurred properly because it's not taking the distance into account. It's just taking how far... Actually, no. Does it work all right? Let's go and try this with just one right here. Interesting. Looks like a gas flame. Yes, it does. Yes, it does. I do wonder why it's not... So if I do this, this will make it calm down over time. Let's set this to 0.99. It should settle. Okay, yeah. I don't know why the wavelengths are quite like that. Yeah, I don't know particularly why they're spreading out quite like that. So here we have that, and that just does the thing indefinite. Oh, wait. I want this to be 0.001. I want only one to fire. That's why. Okay. So if I do this, only one of these... I have this at 0.2 and 0.1. Okay. Oh, that's why. That is why. Must be 51. So that there's always one directly at the center. There we go. Okay. So here we should see. Let me go and reduce that part. I don't know. It still looks like we're getting that wavelength that we've been getting. Let me go and up the impact of it even more. Okay. So here's that. There we go. Okay. It's a little hard to see. Okay, let's go and... What if I were to extrude the faces? There. Oh, that's cool. That's some cool stuff right there. But you can see the waves are working as intended. What did I change? Oh, I just started... Yeah, I just changed the initial drop to be more harsh instead of the much more forgiving version that I had before. And this isn't an accurate representation of it because the extrude is happening on the faces, obviously. So if I want an accurate one, I would instance squares on here and then change either the position or the scale to do the thing accurately. Which, speaking of that, why not? Actually, dang it. Let's set this to vertices mode. I'll keep that, but then I'm just going to use a set position node in post. Because, again, this is kind of setting the position of the object. So let's just see it on the z-axis. And that should probably be a vector math, but so that I can edit it. But here we go. Looking a little slower than usual. Shade smooth. Set shade smooth. So there we go. Yes, city skylines water. So the reason it is slow is because, oh right, that part. So if we do that, it's a lot faster. There we go. Looks like a quantum wave function. Well, a quantum wave function is a wave function, so yes, that does make sense. But one thing that we can see here, we're seeing one of the errors in the blur. So as we can see, this isn't a perfect sphere. We're seeing it get more square-like as it goes to the center, which will lead to inaccuracies. So, yeah, that's just an error with this, again, being that. What if I were to triangulate? Triangulate. Plug that in there. What happens then? Ah, okay. So it's not accurate. It slants it to one side. Okay. Very, very interesting. So if we had it all on one level, that would be incredibly interesting. Hello, Wendy. Here we are doing very complex wave math. So, yeah, there's, let's just say a lot of stuff happening at the moment. A very long process. We are more than 1 hour and 36 minutes into the live stream. And during this time, I've reviewed Blender 4.0's changes when it comes to geometry nodes, but also incidentally figured out how to do actual wave math, which I've been trying to figure out for a while. Let's check the chat once again. Perfect background music. Why, thank you. It's lo-fi Zelda music. Looks like a gas flame. Yep, already read that. I would recommend Grat Abbott's channel. He has a playlist teaching this and a lot of other good stuff. Yes, Grat Abbott has a lot of good Blender content. I'm not up to date on whether or not he has geometry nodes tutorial content, but my recommendations for that would be Arendelle has a lot of good content, very advanced content, but also some beginner content. They made an actual beginner course, which I don't make courses, once again, because a lot of my work is very impromptu. It's like, okay, let's figure out wave math right now. Plans go out the window fairly quickly, but sometimes we get other cool stuff. So originally, just to showcase how off the rails this project became, originally this was supposed to be piano keys that just waved like this. So that was the initial plan, and then I was like, wait a second, I can visualize it using this. Then I realized, wait a second, the math that I set up will work in 2D space and 3D space, which I really want to try the 3D space version, because that will be absolutely incredible. But yeah, very, very cool stuff. So again, here is, whoops, let's switch back to the 2D version. So here we can see the wave math. Something still feels a little bit off with that version. Is it because... Yes, this is the entirety of the wave math. There's the start effector, which is the empty, just gives it a little bit of boost energy right there. And then this part right here is just the entire part of the wave math. I think I'm still doing the target rotation a little bit wrong, but I can figure that out next time. But there it is on just one line, and then we can transition to a 2D plane, which is very cool. But I also want to try this in a 3D environment, which I do wonder how that will work, because using a grayscale value, yeah, how would that work? This is a grayscale value, just a gray value, just one number. Unlike a vector, unlike a UV map, which is 2 colors, unlike a vector, which is 3 colors, this is just one color. But technically, a color is made up of 3 values, so this is just one value. Again, lots of math. But this is the cool nerd stuff that you do. Again, I am tired, so Tired Ben really likes hyper-focusing on the math. So what the heck? Let's just try the 3D version of it. Even though I should be doing this tomorrow, because I'll have RGB, I know that one. Yes, red, green, and blue. The red, the green, and the blue are all single values, but when you combine them, it becomes a color. So this is just using like just red, or just green, or just blue. Only one of those values. And I can visualize, oh, I should have been doing this before as well. Because we have the data stored as a named attribute, I can go and, oh no, Node Wrangler is bugged, which I actually saw something about that in the dev chats. I'm using 4.0 for this, but this simulation could be done in 3.6. Okay, and I need to set the material in post because, well, one, the mesh is generated in post, and also materials don't work with simulation nodes. But here we can see the data that is happening. It's not the best because some of the data goes underneath, it goes into the negative. But here we can see the actual data. There you're seeing the gray values. The gray values are the actual data that is being simulated, which is very cool. If I go and just raise some of the values up, there we go. We can see that. It's a little bit soft at the moment. I could multiply it to make it a lot more apparent. Here we go. Though it is interesting seeing that is allowing me to see a couple of the bugs. Because it's only blurred once, that happens. But here we can see a much more consistent one. But if we blur a bit less, we get an even more consistent result. Oh wait, no, this isn't triangulated. The triangulation makes the blurring work a bit more weirdly. Let's try this. Triangulate. So here, yeah, that gives an even more consistent result as well. Even though it's not accurate because, again, it's slanted to one side. Whoa. That is trippy. Because I accidentally disabled the wave value. There we go. So in theory, this is interesting. This could be used for possibly many interesting effects. I know some people have made like sedimentary, like erosion simulations using something like this. Oh, I also like how this kind of reveals the crisscross of the grid. My voice is giving out a little bit because I've been streaming for 1 hour and 43 minutes. Again, when you get absorbed into the math, when you go into full nerd mode, it's amazing. But also, you know, you can get entrapped in the math. You can go too far to the point where you can't come back. But because this actually turned out to be successful, I'm okay with that. Is it possible to poke faces in geometry nodes for some more evenly distributed triangles and vertices? Possible, yes. Do I know how to do it off the top of my head? No. If you want just evenly distributed triangles, actually wait, I do know how to do it, but it won't be a proper grid after that, so let's just take a look. Triangulate the mesh, we have those, which is nice. Then we use a set position, and then we blur the position. There we go, so blur, just a simple thing here, set this to vector. There we go. So now we can see. Eventually, if you blur it enough, they will become equidistant from each other. As we can also see, it's a little iffy. One thing I like to do, let's go and rewind, is I like setting this to fixed or fixed alternate. Then use a random value to switch between the different methods. So like that, and actually, wait, we don't need that. The only ones, well, I guess it's fine either way. It makes it more efficient. So here we can see that it'll make a random amount of these switch their triangulation orientation, if that makes sense. And then when we blur that, that gives us a much more equidistant mesh, even though when it comes to the bounds, it kind of freaks out. So the middle part is fine. So if I were to put this into the simulation, we'll see that we get a much more accurate result, but not super duper accurate. Oop, let's connect that to the output. Take a look at it. And realize that since the center vertice is offset by a bit, it is not doing its job. So let's go and fix that. There we go. So here we have a much better version of the effect, but since there's still there's a little bit of errors, it leads to noise in the waves, causing them to go out of sync. But yes. You could just generate a kind of hexagonal triangulation thingy, my bopper. Again, my tired brain is going into full effect, so I will need to end the stream soon. I am 46 minutes over what it should be. But I really want to make the 3D version of this. I'll do that tomorrow. Restraint. I need to keep my brain in check, because, you know, if I do everything in one night, then it'll be like, oh, why do everything the next live stream? Which I plan on doing the next live stream probably midday Eastern Standard Time tomorrow. We'll have to see, because there is a big storm approaching. This week has been, or the past couple days, and this upcoming week is going to be stormy, because we're getting hurricane remnants and all that. Around 1 or 2 days ago, my power got knocked out, my internet got knocked out by a storm for quite a while, and that was very annoying. But yeah, lots of interesting stuff. So I'll wrap this up now. Thank you all for watching. Once again, for those of you who are interested, this is the wave math. I'm just putting the line part back here. This is the entirety of the actual wave math. It's for the rotation, because originally, once again, this was supposed to be piano keys. Piano keys just doing a wave kind of thing, which is very funny. Oh, and again, here is the... Oh, wait. Here we go. Here is the... Like, when you snap, like, a jump rope, or, like, when you snap a carpet, you put it up, then it goes back down, and then do-do-do. Does the do-do-do thingy. As you can tell, once again, I am tired. I should stop streaming. But yes, and then when we have this version, we have that. If you set the target rotation to 0, you get the kind of what I call the space slinky effect, where the velocity is still going, but it gets transferred from part to part. And then you'll need to set that to 1 so that no energy gets lost. But again, very interesting math is being developed here, and all that. There we go. Thank you all for watching. This was a very interesting live stream. I really am enjoying this, which I'm surprised by. Recently, geometry nodes and all the math has really burnt me out. But this time, it actually turned out well. So I'm looking forward to what comes next with this. Alright. Pick a good thumbnail for the video later on. I think that's good. I think that gets the point across that we're dealing with waves. Here we go. Thank you all for watching, and I will see you all next time. Have a good night. Or day, depending on your time zone.